This is lesson 7.10. It is multi-step problem solving with fractions. You can't learn math by watching, you have to do it, so get some paper and a pencil and pause whenever you need to. We always start out very basic and over explaining the model, and then pretty soon you cut out that step and go straight for the problem solving, which a lot of it is in your head, but to begin, here's an over explained explanation. So I want to buy dates to give away for Ramadan, and I want to put them into 1 pound bags to give away. But they are sold in 3/5 pound bags. So I want to know how many of these 3/5 pound bags will I need to repackage them into a 1 pound bag to give away without having any leftovers. So to think about that, I start by just going in an organized way, starting with 1 bag. If I bought 1 bag, so this is the 3/5 pound bag, so 3 out of the 5. That's not even 1 whole pound, so I need more than that. What if I bought 2 of these 3/5 sized pound bags of dates? What this is showing me is that I have a 3/5 and another 3/5, and what will that be? That's going to be 6/5. So is that going to equal a whole amount? So I could model that. Again, you'll cut out the models pretty soon. So if I put these together, what do I get? I get 5/5 here and my leftover 1/5. So what is that? That's 1 and 1/5. That is not going to be a whole amount. I'm going to have a 1/5 piece left over. So then my next step is I would say, okay, what if I bought 3 of these 3/5 pound bags? So here's where we can take away part of the model. What we would end up modeling is we would add another model, add it into our whole, and we would see that we're still gonna maybe have something left over. So without modeling it, what if I just did, so here's 2 of them. So here's where we don't need the model anymore, but we should understand what's happening as we're buying a 3/5 bag, 3/5 pound bag, and a 3/5 pound bag. How many is that altogether? Again, add the numerators or just understand we're adding all of these parts together. The denominator stays the same because in our model, the size of the piece is still a 1/5 sized piece. So how many of those 5th sized parts do we have? We have 3, 6, 9 5/5. How do I write that as a mixed number? So again, if you know the shortcut, think of it in your head. The shortcut is, this is basically dividing. 5 times what is close to 9? 5 times 1 is as close as you can get. So I know that I have 1 whole in there. That means there's 5/5 hiding in here. So if I just think of that, if I take away my 5/5 from 9/5, how many is left over? There's 4/5 that are left over. So that would be my remaining 4/5. Okay? If you don't know that step really well, you have to know that step really well. So what this is saying is, this is 5/5 plus 4/5. There's my 1 whole, and there's my 4/5. Okay. What if I had, so there's still a leftover. There's still going to be something here. So 3 bags is not enough. What if I bought 4 bags? So 4 bags would be 3, 6, 9, 12. 12/5. Is that going to be a whole amount, or will there be leftover? So again, if you know the shortcut, 5 times what is close to 12? 5 times 2. So that's my whole amount. That's 10. 10 is how far away from 12? It's 2 away. So there's going to be 2/5 that are left over. So 2 and 2/5. There's still a leftover, so that's not going to work. If you don't know the shortcut, what you're thinking is there's 12/5. I want to break that into I want to pull out as many wholes as I can from it. So one whole is going to be 5/5. Another whole is 5/5. There's 1 and 1. That's 10. And then what's left over? 2/5. Okay. So here's how you get the long way, the thought process, and the short way is you do it all in your head of it's basically dividing and then how many parts are left over. So 4 bags is not enough. Let's try 5 bags. So 5 bags, 3, 6, 9, 12, 15. 15/5. So you should already kind of tell just by looking at it that we're going to be okay. But if you couldn't tell right away, you would still do the 2 methods. The thought process is you're dividing 15 divided by 5, or how many holes are there that are hiding in there? How many 5/5? There's 3 of them, so you're going to have 3 holes. Or basically 15 divided by 5 is 3. Your longer thought process is how many holes can I pull out of this? How many 5/5 are there? So 1, 2, 5, 10, 15. There are 1, 2, and 3. So there are 3 5/5 that are in here. So that means that can I have my dates repackaged into the bags without having any leftovers? Yes. How many bags would I need? I would need 5 bags. Okay. So that was a long process to solve the problem. Again, you're going to cut out the models and go straight for the math, and pretty soon you're going to find patterns that can cut out a lot of these steps. But your thought process is organized and you're staying very clear with your steps and very clear with your numbers. So try this problem. I jogged 1 2/3 of a mile for 5 days. How far did we jog altogether? So again, you're going to be adding all of the parts. So for 5 days, so the 1 whole, that's an easy thing to represent. It's just 5 miles. So we'll leave that over here on the side. How am I going to represent 2/3, the 2/3 part of the mile for 5 days? I'm just going to write that 5 times. And if I add those all up, 2, 4, 6, 8, 10, 10/3. Now what do I do with the 10/3? I see how many whole amounts are in it. So again, if you can go to the thought process, do it with division, or think of it like this. How many 3/3 are there inside of 10/3? So there's one of those, 3, that's 6. Here is 9, plus my leftover 1/3. So if you do the math backwards, this is 3, 6, 9, 10 thirds. So how many holes are in here? There's 1 here, 1 here, 1 here, and my 1/3 that's left over. So if I add these parts to my whole amount that I had over here, what would I have? I would have 5, 6, 7, 8, and 1/3 mile. So my answer would be 8 and 1/3 miles altogether. Okay, last one. These questions are long because it's the problem solving section. So they take some time to read the question, understand it, and then model it. So at the end of a family dinner, there are many pie pans left over with leftover pie. Each pie pan has 2 5th-sized pieces of pie left in them. Afterwards, we're going to combine all of those leftover pieces of pie, and it will end up making 2 full-sized pie pans with all of the leftovers. So we want to know how many of those pie pans did we combine to get our amount at the end. So the first step is just understanding and visualizing what is this even, what is this showing me? So this is saying that if I had a pie pan and it's a 5th-sized piece and there are 2 pieces that are left over, that means in one pie pan there are 2 pieces left over. And we want to know how many of these half completed pie pans are there that we can combine the leftovers and then make a full amount. So if I only had one leftover, that's not enough. That's not even a full amount of leftovers. If I had 2 or 3 or 4, so same as the other questions where we could model it and then add the pieces together, or you can just think of the numbers. So if I just had the numbers, 1 is not enough. What if I had 2 pie pans? So that would be 2/5 and 2/5. If I combine those parts, how much would that be? That would be 4/5. So that also isn't even a full pie. So we have to have more. What if I had 3 of the leftover parts and I put those together? So if I had 3, it would be 2, 4, 6, 6/5. Is that a whole amount? Well, you can either do the shortcut where you are basically dividing and you're saying how many wholes are there that are inside of this 6/5. How many 5/5 can I take away? This part of the lesson, you have to go back to previous lessons if you're not clear on what that means to have a whole inside of this improper fraction. This is saying there's a 5/5 and a 1/5. And what is this? A 5/5 is 1 whole and the leftover 1/5. So this is 1 and 1/5. So you have to know how to do that step of going from an improper fraction to a mixed number. 2 ways you can do it. You think of division, or you can do the expanded way. So this is not enough. You still have a leftover amount. So what if I had 4 original pie pans with those leftover pieces, and I put those together? Change the color. So now I have 4 of them, 2, 4, 6. This is 8/5. Is that a whole amount? So again, either break it apart and take out the 5/5. How many 5/5 are there? There's a 5/5 plus, so what is going to equal 8/5? 5/5 and 3/5. So that's 1 and 3/5. The other way you think of it is with division. 5 times what is close to 8, so 5 times 1, there's only 1 whole in there. And how many 5th sized pieces are left over? Well, there's 3/5 that are left over. Okay, so that also is not enough. What if I had now 5 pie pans? So with 5 pie pans, 2, 4, 6, 8, 10, that is 10/5, and you should see pretty quickly 10 divided by 5 is 2, and that is what we're looking for. We're looking to say how many of those leftover pieces can we take from all of these pans, put them together on one pan, and have a whole pie again. So we would need 1, 2, 3, 4, 5 partially eaten pie pans to take the leftovers, put them together, and that would give us 2 full amounts. So again, if you don't know the division, what you're thinking is 10 over 5. That is the same as a fifth, and another. So there's your 1 and there's your 1. Okay, so going back to the lessons of going between improper fractions and mixed numbers, that's the biggest thing. The second part of this lesson is just breaking down a word problem, and the only way to do it is to do it, and do it step by step. And once you do that, then it kind of makes a lot more sense than just sitting there being stuck, not knowing even where to start. The best place to start is always with a model if you need to, or just write down something. Write down the information from the problem. There's a 2/5 sized piece. How many of those do we need until we add up to the amount that we're looking for?